Hey guys, so here is part 3 of the 1.7 day 1 notes. We're continuing to solve absolute value equations. Now, we're going to be doing this when we have a variable on the other side of our equation. So number 6, we have the absolute value of 3p minus 4 equals p. So now, whenever you have a variable on the other side, this is when you need to check for extraneous solutions. So I should say when you have a variable on both sides, and so what are extraneous solutions? So I quickly talked about this. Basically what happens is we're going to do our usual. We're going to create two equations and solve for the variable. But afterwards, when we get our answer, we will need to take that number, plug it back into the original equation, and if we get a true statement, then that is a solution. However, we don't get a true statement, that means that's extraneous. So it doesn't actually work with our original equation. Okay, so we are going to create our 2 here. So we'll have 3p minus 4 equals p. Now what we do is we do the same thing as we did with numbers. Anything that is outside the absolute value bars, we negate it, or kind of really just do the opposite sign. So we have negative p. Okay, on the first one, I'm going to go ahead and subtract 3p on both sides. So I get negative 4 equals, this will give me negative 2p. And then negative 4 equals negative 4p. On my first one, I divide both sides by negative 2. So I get p equals 2. And then on the other one, I get p equals 1. So now what I need to do is I need to take both of these and plug it back into the original equation. Okay? So plug back in to the check. So remember, our original equation is with the absolute value bars. Okay, so we have to plug it back into this one. If you don't plug it back with the absolute value bars, you're actually going to get true statements out probably both of them, and that probably will not work. Okay, even if we do plug these back into the original equation, you could have where both of them work. Maybe one of them works or none of them work. So it kind of just depends on the problems. Okay, so let's try when p equals 2. So this is where we're really going to talk about how to take the absolute value of a number. So I have 3 absolute value of 3 times 2 minus 4. And wherever I see p, I need to plug that or plug the number 2 back in. Okay, so I have 3 times 2 to give me 6 minus 4, and that's still the absolute value bars because I have not taken the absolute value of it. Then the 6 minus 4, we have the absolute value of 2 equals 2. Now, I take the absolute value of 2. Remember, the absolute value always makes the number positive, no matter if it was originally positive or if it was negative. So the absolute value of 2 is 2, and so we have 2 equals 2. Is that a true statement? Yes. So that means p equals 2 is a solution. Now, let's try when p equals 1. So I'm going to do the same thing, plug it back into my original equation. So I have the absolute value of 3 times 1 minus 4 equals 1. So I do 3 times 1, that gives me 3 minus 4, that's still in the absolute value bars. Well, then we do 3 minus 4, that gives me negative 1. Well, what's the absolute value of negative 1? That's going to be positive 1. And so we have 1 equals 1, that is a true statement. So both of these actually work. So here we have 2 solutions, p equals 2 and p equals 1. Okay, let's go and do the next one. Okay, number 7, I would like you guys to go and pause the video and try this one on your own. Okay, let's see what you got. So once again, we have a variable here. So since we have a variable on both sides, we have to check for extraneous solutions. Okay, so I create like two equations without the absolute value bar. So I have 4d plus 10 equals 6d. My other one, I'm going to negate the 6d. So I have 4d plus 10 equals negative 6d. Remember, anything that is outside the absolute value bars, you negate it or do the opposite sign. Okay, now I solve. So on my first one, or on both of them, I'm going to subtract 4d. So I get 10 equals 2d. And then 10 equals, I think that'll be negative 10d. And then on my first one, I divide both sides by 2, so I get d equals 5. On the other one, I divide by negative 10, so I get negative 1. So now we need to check both of these in the original equation. So the original equation is the absolute value of 4d plus 10 equals 6d. So let's try when d equals 5. Okay, so I have the absolute value of 4 times 5 plus 10 equals 6 times 5. Okay, from there, I'm going to go ahead and do 4 times 5. So I have the absolute value of 20 plus 10 equals 6 times 5, which gives me 30. Now I add what's inside, so I do 20 plus 10, so I get the absolute value of 30, which equals 30. I take the absolute value of the 30, which that should just give me 30. And so I get 30 equals 30. Is that a true statement? Yes. So d equals 5 is a solution. I can box it. Now I need to try when d equals negative 1. So we have the absolute value of 4 times negative 1 plus 10 equals 6 times negative 1. So 4 times negative 1 is negative 4, so I have the absolute value of negative 4 plus 10 equals negative 6, because 6 times negative 1 gives me that. Then negative 4 plus 10 gives me 6, so I do the absolute value of 6 equals negative 6. Absolute value of 6 gives me 6, but I have 6 equals negative 6. Does that work? No. So that means d equals negative 1 doesn't work. That is extraneous. Okay, so we just write it's extraneous and we do not box it. So here we only have one solution, d equals 5. Okay, let's go ahead and do our last problem. Number 8, we have the absolute value of 1/2 x minus 4 equals 10. Now here, do we see a variable on both sides? No. So in this case, we don't have to check for extraneous solutions. Whatever we get as our solution, that will work. Okay, so now we do the same thing. So actually what I would like you to do is go ahead and pause the video and try this one on your own. Okay, let's see what you got. So my first equation is going to be 1/2 x minus 4 equals 10. And then 1/2 x minus 4 equals negative 10. Okay, on both of them I add 4, so I get 14. And then on this one, 1/2 x equals negative 6. Now, how do I get rid of this fraction? Now, you can say divide by 1/2, that's fine. But if you do it that way, make sure you plug it in when you do it in your calculator. Like you do 14 divided by parentheses, 1 divided by 2 into your parentheses. Because otherwise, if you don't do that, you get the wrong answer. Another way we can do this is what we call multiply by the reciprocal. So that means for both of these, I can multiply both sides by 2. So the 2 1/2 cancel, so I have x equals, I do 14 times 2 to give me 28. Now the other one is the same thing, so 2 times 1/2 cancels. So I get x equals negative 12. So these will be my two solutions. Okay. So I just wanted to do this because we haven't worked with fractions too much. Okay, make sure you guys work on the homework assignment. And if you have any questions, make sure you contact me. I'll see you guys later.